Hi everyone, welcome to another OpenPOWER Developer Challenge Hangout. Today we wanted to take some more time taking you through a very powerful tool for you that you can use particularly in the Open Road test for porting and optimizing your application on OpenPOWER. This is the Excel compilers that are delivered by IBM. You can use the full version of the compilers in SuperVessel. And now, through the Community Edition, the Excel compiler suite is also available for free out there in the regular marketplace. So we'll go ahead and get started. I would like to introduce Yaoqing Gao. He's a senior technical staff member at our Excel compiler team based in Toronto. I'll hand it over to you, Yaoqing.
Thanks, Beth. Today, I'm going to talking about how to use IBM Excel C and the Fortran compiler on the SuperVessel. Let me share my screen. My talk today will cover the following. First, I'm going to give a brief overview of Excel, C, C++, and the Fortran compiler. Then, I'm going to give the step-by-step instruction how to set up and using Excel compiler on SuperVessel. After that, I'm going to talk about how to do the performance analysis and the tuning. And in the end, I'm going to take a few minutes to have the quick demo. IBM Excel C, C++ Fortran compiler are built on the common compilation technology to support the C, C++ Fortran on the IBM platform. We have a C, C++ language standard conformance, Fortran 2003 conformance, and we have selected Fortran 2008 features. We also support the OpenMP 3.1 compiles and also selected OpenMP 4.0 and 4.5 features. Excel compiler also supports the GPU exploitations. We have the C++ host compiler integrated with NVIDIA CUDA C++. We also have our own CUDA Fortran compiler. Excel compiler advantage is to deliver the industry-leading performance and fully enablement and the exploitation of power architecture. And support the advanced compilation technologies. We also, within the Excel compiler package, we also have the optimized math libraries. Compared with the open source compiler, the typical Excel compiler can deliver the 10 to 30% better performance. We also have the world-class service and the support. This is the answer why using Excel compiler. The compiler technology, advanced technology included the full exploitation of the latest hardware features. We have very aggressive loop transformation and auto summarization, and which are typically for the analytic technical computing HPC workloads. We also support the parallelization. The parallelization included auto parallelization and the user explicit parallelization through the OpenMP. In the package, we have optimized the math library. We have a scalar version of the math library, also have vector version of the math fee library, tuned for the power. We have matured technology for interprocedure, or some people call it the whole program optimization. We also support the performance feedback optimization, tuned for the typical user scenarios. For easy migration, Excel compiler supported the compatibility at the source level and the binary level with GCC and the CLAN. Given the the source code compiler with GCC, and you have the makefile, so typically you don't have any major changing. You can easily to migrate the code to using Excel compiler. Excel compiler adopts the Clang technology for better GCC compatibility and full Clang compatibility. And at the binary level, if we are fully compatible with GCC, that means if you have the code compiler with GCC to get object file, this object file actually can link with the object file generated by the Excel compiler without any problem. So now let's get into the next topic, how to set up and use Excel compiler on the SuperVessel. Excel compiler on the SuperVessel consists of two images. One is XLC Community Edition, which offers a limited license and entry level for free. This is available on the default open road quick start image. We also have the XLC C++ Fortran compiler in the separate image, which have the both CUDA and OpenMP support, and with full optimization enabled. So now, first step, you log on the SuperVessel. In the service zone, you can click apply the VM, and you create the VM. Step 2, in the left side, you can see the image marked, and you can click the image marked to select the image. So you can see have an open load quick start image that's including the XLC Community Edition. You can also take advantage of the full version of XLC, C++, and the Fortran compiler, which are available in the separate image. You click the detail and then click the launch, and the image will be created. You can follow the instruction to connect the VPN. Then you can use SSH to connect to your instance. Now you are ready to using XLC and XL Fortran and the CUDA 7.5. So now, under the image, the Excel compiler actually is installed in the default path, user/bin. So you can using the XLC check the version, and you're using the -q version. You can also using the GCC, the syntax, the option, that's where -- versions to check to verify the compiler versions. For the C code, if you're using Excel compiler, you are using the XLC to invoke the XLC, the lowercase c, for C applications. The XL capital C for C application. You can use XF 1995, 2003, and 2008 for Fortran applications. Then you can specify compiler options, the optimization level, like the O3 to compile your applications. Depends if you are using the OpenMP, you can add the OpenMP option, that's -qsmp equal to OMP to enable the OpenMP applications. So if you have the CUDA C++, you want to use the CUDA C++, and you you need to specify -cc bin, specify the XLC, NVCC, CUDA C++, NVCC from the NVIDIA, they have the GCC, set the GCC as default. And you can just using the option to specify the XLC, to invoke the XLC as a host compiler. If you have the Fortran CUDA, and then you can use the XL CUDA Fortran, and that is you just XL CUF to invoke the CUDA Fortran. The chart here to show the compiler option for XLC, for GCC, and the CLAN. If you look at the option, XL compiler, majority of the options are common. For example, XL compiler supported the -0, supported -02 and -03. And compared to GCC and the CLAN, XL compiler supported a high optimization level, like the 04 and the 05. Later, I would like to emphasize that majority of the GCC and the CLAN option, XL compiler supported the majority of the GCC and the CLAN options. So in most cases, if you have the application, you are already using the GCC, you are already familiar with GCC, you can just using that option and without any changing, and you can switch to the XL compiler. So now I'm going to talk about how to do the performance analysis and the tuning using XL compiler. So this is mainly for advanced user. For the majority of the user, you can just using the 02, 03 option to get a reasonable good performance without any the in-depth tuning. But if you want to get the maximal performance, you probably would like to do the fine-grained tuning. But first, you need to identify what's the hot spots, what's the bottleneck. To do that, you need to gather the profiling information, timing information, and the performance tools like the GPerf, OPerf, perf, and even compiler instrumentations you can use to identify the hot spots and detect the bottleneck. I would like to recommend the perf. Usually, if you're using the perf tools, you can get the majority information. Further, using the perf, you can also get some performance counter information. And then the information like the fixed point, floating point events, catch miss events, branch miss prediction events, load store units events. Based on that events, you can identify a workload is competition intensive, or memory latency intensive, or bandwidth intensive, or I/O intensive. Based on the information, you can decide what kinds of optimization you apply. So for GPerf, most of you probably already familiar with GPerf, and when you just make sure when you compile applications, you add -PG options to do the instrumentation. Then you run application and using the GPerf and to get the profiling the data. For the OPerf, you can using the OPerf helper to list the available events. Then using the OPerf and using -E specify the events, and then using the OPerf report to get the profiling information. And the perf, the tools is one is most popular. Actually, I strongly recommend you just using the perf. And the perf is very easy to use. When you have an executable, what you do is just the perf record and run your application. And then you perf report to analysis the profiling information. So after you have the profiling information, then you would like to know how to do the performance tuning using the compiler optimizations. XL compiler support the unique feature we call the XL compiler transformation report. The compiler can generate a report to tell the user what optimization performed by the compiler, what optimization cannot confirm performed by compiler, and when possible, to give the reason why. So user can using the transformation report to generate the text format, HTML format, or Excel format, the information to do the analysis. The HTML format, you can use any browser to view the information, to navigate the compiler transformation report, and to check what optimization performed by the compiler, and what optimization cannot be performed by the compiler, and with possible reasons. And the Excel compiler also generated HTML format, and user probably you can write their own tools and to consume the transformation report to do the performance analysis. So here gives the example how to using the compiler transformation report. Given the source code, you have the C code, you have the simple loop like this, and this loop full, you have the points PQR, the point passed to the parameter, and the loop using the PQR point to access as a relay. So you can add the option Q report that will be generate the text information, and you have the list MAT format, specify HTML to generate the HTML format, or using XML to generate XML format. After that, after you compile the code with option, the compiler will tell you the loop cannot be symbolized because of the data dependency. As you know, the PQR, the compiler cannot figure out the PQR potentially will point to the same memory location. But if user know that you definitely know the PQR wouldn't point to the same memory location, and then you can either add the restrict the keywords that tell the compiler PQR are disjoined. So if you compile the code again, and the compiler will generate the report to say the loop was symbolized. So this is show you how to using the compiler transformation report to do the performance tuning. Excel compiler support the 5 levels optimization level. We support 02, 03, 04, 05. Now the question is, what compiler optimization levels I should use? Actually, it's very simple. Typically, when you do the performance tuning, you start from the 02 and the 03. In the most cases, you already get reasonable good performance. And if you want to get the maximum performance, and you probably want to do the further tuning, and then you are using the performance tools to do the profiling to identify the hard spots under the performance bottleneck. If you know through the profiling information and also through your domain-specific knowledge, if you know the code is floating point competition intensive or memory intensive workloads, so typically you also want to add -Q hard to enable aggressive loop transformations. If you have the CC purpose is integer program, you have lots of small functions in the different files. And in that case, you probably would like to add the profiling, so add the whole program optimization, that's a -Q IPA, or using the 0405 that enable the aggressive optimization class the files. Further, if your application have lots of branches and you would like to consider using profiling direct feedback optimization, And this will need to be the 3-step. First step, you do instrumentations. You're using the -Q PDF1 to generate the instrumented executable, and then you run the application with a typical input data set. And the executable will generate the profiling data. After that, you recompile your code with QPDF2, and then the compiler will using the profiling data to generate in the PDF1 and optimize the code based on the profiling data to generate optimal the executable. And you run again, you will see more than 10% improvement. And if you have the OpenMP, if your code is a parallel code using the OpenMP, you can use SMP equal to OMP. If you want to enable the auto parallelization, you can add the -Q SMP equal to auto. For the code you want to the GPU, you want to use the CUDA, and you can add the CUDA option to enable the GPU exportations. We have the few resources, to how to use in the XL compiler. The link here that show all those information. You can also join our CC Purpose Fortran Linux on Power community to answer the question. We also have the OpenPOWER Slack channel for you to ask the questions. We monitor the channels. We are trying to respond quick. You can also follow us on the social media, on the Twitter, Facebook, LinkedIn, and Google. So now I'm going to have the live demo how to create the setup of the XL compiler on the SuperVessel, how to use the XL compiler, to do the tuning.
Yaoqing, while you're setting up, I just wanted to let everyone know that I think Yaoqing has been sharing a lot of links, and I highlighted those in the showcase for this Hangout, but I'm not quite sure how that comes through in the replay of this. So if you're watching this asset in a replay, you can find this presentation and all the links through the resources area of the DevPost site. So there's a link to a folder on Box that has a bunch of miscellaneous resources. So this presentation that Yaoqing just gave you is available for download there.
So now I'm going to have the live demo, and let me share my okay. So first, you log on the SuperVessel. You will see in the service zone, you can apply the VM. Assume you already have the OpenPOWER ID, and you can log on that. Okay. In the dashboard, the left side, there are the image marked. You click the image marked, and then they show the open load quick start. And this image contained the XLC committee edition. For most of you, XLC committee edition should be sufficient. So most of you, I will assume, you can just use the OpenPOWER quick start and click to create the instance. For some advanced user, you would like to use the full version, the CC purpose, and specifically you also have a Fortran code. You also want to enable the GPU. You can use the XLC version 13.1.4 XF Fortran 15.1.4 Linux compiler this image. Now you click the details and click the launch and the instance, and then the launch the marked image, and the instance will be created. So now you see I have the two images. One I created yesterday, and the new image I just created now. And here you have you can see the external IP address, and initially the password for root and for the user. And you can first you can click the console and change your password, and then so you can see I have the instance here, and you can click the icon and to click the icon to get the VPN user account and the password. After that, you can using SH to connect to the server using the external IP address. So now we're going to SH. I'm using SH to the instance. I'll put a few examples in the image. Look at first, I would like to show you a small, simple example. This is a C purpose code, and this code I have the template and to create a template for the different data type. And the main loop actually is just to do the one array multiply the constant add another array to assign to third array. This is the code is extracted from the string benchmark. So now let's compile the code with XLC. So since this is a C purpose code, we use the capital C, and I just using the O3 to compile this code. So you can ignore this message, and then you can see the executable triag O3 is generated. Then, if you want to use the performance tools to identify to gather the profiling data, you can use the perf. You can run the perf to get the profiling data. The perf is very simple to use. You just the perf record. After that, the profiling data, the perf data date is generated. Then you just use the perf report to look at the profiling data. if you look at the profiling data here, you can see majority of time is spent the do work with different data type. You can further look at to find the hot spots. If you're using the capital H to search that, they will highlight the hottest spot. So from the profiling data, you know the hottest spots is in the source code do works. So now, and also you see the do works lots of time spent on the add and the multiply. So, and also you look at that, I have the triangle floating point, this F dash F means floating point, and the number is the size of a data type. I have A bytes floating point, that means double, and also the float, and also have the integer, and the 4 bytes integer and A bytes integer. If you look at the time, the second under the colon second, you see the time spent on the each routines. So now I go into using the add the hot option to compile this code again and look at the performance. Since I know this code is a floating point and the integer computation intensive, I want to add the hot and to do the more aggressive optimization. Then I would like to run this code again and check the performance. So if you look at the timing, the seconds column, and you will see the huge performance improvement. And you can see some code is if you compare the FA, you almost see the double performance improvement. And if you see the F4, you even see almost 5 times the improvement. So this is a show optimization levels affect the performance. And as I mentioned before, Excel compiler can generate the transformation report in the HTML or text or XML format. So if you want to generate the text format, you just add a -q report, and the Excel compiler will generate the listing file, including the transformation report. And here, if you look at that, they will tell you the loop at the lines 26 was simultaneously vectorized. So this will tell you that this loop already optimized. And this is in the text format. You can also generate the HTML format. So that's add the LSTFMT HTML. So in that case, we will have the HTML format. For this HTML format, you can use in any browser to look at that, to navigate the transformation report. You know the what optimization performed by a compiler and what optimization cannot perform by the compiler with possible reasons. So I have, for this HTML, let me just download that and see I'm trying to switch the window. I mean, to show my browser. Yeah, okay, I think I have some difficulty to that. Okay, so basically the HTML format, you can use any browser to navigate the transmission report. So, okay, so I give the overview about the Excel compiler and also how to set up and using Excel compiler on the SuperVessel, and also how to do the performance tuning with Excel compiler. We have some material on the resource in the Slack and also in the social media, and I'm going to hand over to the Beth for any questions.
Okay, thanks so much, Yaoqing. Yes, so I already mentioned, but in case you just tuned in, just want to reiterate that the deck will be available for you to download in the resources folder on Box, which is shared through the resources page on the challenge site on DevPost. And I don't see any questions coming in live right now, but I would encourage anyone, as you have time to watch the replay, go ahead and you can find us in Slack. You can find that through the challenge website. And there's also a discussion forum in there for you to ask questions. So with that, I think we can wrap it up. And I appreciate everyone taking the time. And thank you so much, Yaoqing.
Thank you.
Right. Bye, everyone.